So today we're going to continue our discussion on the different types of data structures. We already discussed the vectors. We say the vectors are only limited to one data type. And also we have lists, which where we can have several different types of data types, whether it's numeric or character, logical, date, etc. Okay. Now we go to the third structure, data structure, and this is a very important data structure. We're going to make use of this throughout the course, data frames. So a data frame is a table, or it's a two-dimensional array-like structure. So it has a row and a column. Now there are several requirements for it to be considered as a data frame. The column name should be non-empty, means that the column should have a name. The row name should be unique, if there's a name. The data can be of numeric, factor, or character type. And each column should contain the same number of data items. Okay, so let's have an example. Do you recall, guys, what's the meaning of this parenthesis here?
Yes, sir.
What does this mean, the parenthesis here? Do you recall? This parenthesis what will it do? It will automatically print. Yeah, automatically print and give us the result. For example, we're creating an object called n, and it is a combination of 2, 3, 5. So if I run this, notice that it prints the elements of n, 2, 3, 5. And if we look at the content of the object that's already loaded or available for use, it's n here. It's numeric, consisting of 2, 3, and 5. Okay. Well, that's a vector, right? If you recall, this is a numerical vector. Now let's create another vector of S, okay, which is vector called S, which consists of 3 character variables. Okay, there. So A, B, B, C, C. So this is a vector of 3 elements consisting of characters, and then also a vector of 3 elements, logical values, true, false, true. And then what we do here is we create an object called df, and we impose that this should be a data frame, data.frame, and it consists of n, s, and b. The n, s, and b, these are our vectors, n, s, and b. So let's run this. Okay. So now we have this object df. Okay. It consists of 3 observations of 3 variables. It's n, s, b. So there are 3 rows and 3 columns. Now this object df is what we call a data frame. Okay, it's called the data frame. All right, so let's take a look at the requirements for a data frame. Number 1, the column name should be non-empty. So each of the column has a name. Okay, so sorry about that. Each of the column has a name n, s, b. Okay, and then the row names should be unique. Okay, we didn't give it a row name, but since we imposed it to be a data frame, the default was to give it just a number 1, 2, and 3. And the data can be numeric, factor, or character type. So we have here a numeric data, a character, and logical. Okay, and each column should contain same number of data items. So 3 items, 3 items, 3 items. So this is a data frame. So most of the data that we will be working on is of this type, a data frame. Okay. But let me close this first. Let's have another example. Okay. So here we're creating this. If you notice, this is it's a relatively long code compared to what we did a while ago. Here we're creating an object called emp.data, and then we're imposing that this should be a data frame, okay? A data frame, and it consists of this row, employee underscore ID, and this consists of round, run if 10, 100, 999, and 0. Okay. So let's just first look at the different elements. Then comma. Then we have here employee name, and it concatenates these names, week, done, etc. And then salary, it's a combination of these elements. And then start date, the name of the object or the column is equal to as.date. Okay, so this converts it into a date. And then strings as factors is equal to false. I'm going to explain what this strings as factors is equal to false. Okay, so let's first take a look at this. How many let's see, how many columns will we have here? How many columns will we have for this data frame once we run this? Anyone?
3.
Yes, sister?
Okay, 3, 4.
Yeah, 3 or 4. So let's count it. Employee ID, employee name, salary, and also the start date. Okay, the start date will
4.
also be, yeah, there will be 4 columns. And let's see, will they have the same number of items per column? For the first one, for employee ID, how many will there be?
10.
Yeah, 10. So we're asking R to generate random numbers, 10 all in all, from 1,000 to 999. Okay, the 0 there means the number of decimal places per number. So this is these are just whole numbers. Employee name 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 names. And then for the salary, if we count this one, we will have 10 quantities here. And then start date, if you count this is also 10. Okay, so we can create a data frame out of this because there are 10 elements per column. Okay, otherwise it will not be run if there's one missing element. Now the item here, strings as factors, is used to denote that the character variables, in this case the names, Rick, Dan, etc., these names will not be treated as factors. Now what are factors? Factors are also character variables that you can use as classifiers. Okay, for example, gender can have female, male. Okay, those are also character variables, and then you can use them as factors or classifiers. You can have, let's say, country. So let's say Philippines, Indonesia, Malaysia, Thailand. They are character variables, and you can use them as classifiers. Okay, you can classify those that belong to the Philippines, those that belong to Indonesia, those that belong to Malaysia, etc. Okay, so in this case, the employee name, we're not going to classify them. We're not going to use them as classifiers. We're not going to classify all the Ricks, all the Dans, all the Michelles. Okay, so we are saying here that the strings as factors is equal to false. Okay, any questions about this? About this code, strings as factors?
It means no correlation with the result, sir.
No, strings as factors means that the character variables here, in this case, employee name, will not be used as a factor. What is a factor? A factor is a type of variable, character variable, that we can use to classify. It's a classifier. So as I mentioned a while ago, if we have, for example, residence, for example, where we have data where there's a variable, their residence, so maybe it puts them Manila, Quezon City, Makati, you can treat that variable as a factor. which means that we can classify all those that belong to Makati can be treated as one group, etc. Okay, is that clear, guys?
Yes, sir.
Yes, sir.
Okay, thank you. Ronnie, did you get that?
Yes, sir.
Okay, don't be ashamed, Ronnie, okay? If I'm explaining too fast, it's okay to ask and interrupt me to ask a question. Okay, now before we run this, let's suppose we put here 9. Okay, 9. If we put here 9, okay, by the way, this means that run if, okay, when you run a certain function in R, perhaps you have seen me already type the function, for example, run if in the console, and then question, then run if. I think I already showed this to you. Okay, so I think this one, guys, these functions provide information about uniform distribution on the interval from minimum to maximum. Okay, run if generates random deviates. Okay, this gives us random numbers. N is the number, minimum 0, maximum 1000. Here we're defining it as 9 observations from 1000 to 999. So this will give us different numbers from 1000 to 999 with no decimal places. Okay, the round here tells us how many decimal places you want the number to be. Okay, you want the number to be. Why don't we copy this first here? Okay, Control C. Okay, just to understand what this function gives. Control V. Okay, so I copy the function. I hope you do the same, guys. Okay. Okay, so first, why don't we first use the run if? The run if. Okay. So run if, guys, this gives us 9 numbers, okay, from 1000 to 999. Control Enter. Okay. Now you notice that this gives us, okay, numerical numbers, okay, with decimal places. Okay. And these are numbers between 1000 to 999. Okay. And we don't want that because what we want is an ID. Okay, so let me copy that again. This time I placed here round. This will round off our number, round off, and there will be no decimal place, 0 here. Okay, so if I run this, okay, notice that there are now 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. It generated 9 numbers, and there are no decimal places. It rounded it off. Okay. Okay. So if I do this, if I make it round 1 here, okay, notice that there's 1 decimal place. All right, and of course, guys, as you know, you have different outputs because this is randomized numbers. Unless we, if you want the same numbers, what do we do? Class, do you recall? Do you recall what to do if you want to generate the same numbers? Did I discuss set.seed with you, guys? Have I discussed this with you?
Yes, sir.
Okay, so that's what we do, right? Yeah,
Yeah.
okay. All right. So, okay, so I won't do that now. But if you want to have the same random numbers, we can do that set.seed and then set.seed and then the round function. Okay. Now, going back to our example, we're creating a data frame. Okay. And I place here 9 while the others have 10 elements. Let's see if this will run. Okay, let's see if this will run. I'll run this. Okay, what do you notice? Sister, what does it say?
Yes, sir.
Did you run the code? Did you change the employee ID, did you make it 9 instead of 10?
Oh, not yet.
Okay.
Still 10.
Okay, so kindly do that. Kindly
Okay.
change, and then kindly read to us the result.
Yeah, boss. Error.
Error. Okay.
Error
What's the error?
Error in data frame.
Okay.
Employee ID round 9.
Okay.
And the name, because I think the data so different.
Yeah.
9 and 10.
It says their arguments.
The rows only 9 argument imply in differing number of rows of 9 and 10 of.
Yes, that's right. Okay, that's right. So that's why, guys, now we have been able to prove that if we create a data frame and one of the variables, one of the columns has a different number of rows compared to the others, then it will not run. So this should be a 10 for this for employee data to be created. So why don't we do that now? Okay, let's run it, and there you go. Okay, there you go. So we now have a data frame. Okay, the data frame consists of 4 elements. You have the employee ID, the employee name, the salary, and the start date when the person was employed in that company. Okay, so you can create a data frame using this code. Okay, type of code, you give the data frame a name. Okay, so if you take a look here, okay, we have employee data here in our environment object. Okay, if we click this employee data, it will automatically generate. Okay. Okay. So here we have the data frame, 10 rows. Okay, and we have the employee data, employee name, salary, and the start date. Okay, and most of the data, the data that we're going to use in this subject will be in the form of a data frame. Okay, is that clear so far? Any questions?
Here so far, sir.
Thank you. How about Ronnie? Any questions?
No question.
Okay, good. Thank you. All right. So let's have another example here. Example number 3. Here we're creating this object ID. Okay, ID is a number from 1 up to 200. Then we have here another object called group, and it's a repeat. Rep stands for repeat. So it's a combination of repeat vehicle 100 times and repeat drug 100 times. So this group, how many elements does the object group have? So it repeats the word vehicle 100 times and also repeats the word drug 100 times. So all in all, 200 elements, right? For group, 200 rows. Also ID. How about response? How about response? It will generate 100 random numbers, okay, normally distributed, with mean equal to 25 and standard deviation is equal to 5. And another one, random, normal, 100 also, with mean is equal to 23 and standard deviation is equal to 5. So for the response object, it will also be 200 elements. Okay. So let's run first ID. ID. Okay. There you have your ID. Okay. It's only 1 to 100. Okay. It's an integer from 1 to 100. You can just, if you want to see it. No. Okay, then we have group. How will our group look like? Control Enter. Okay, there. So it's a vector of names, vehicle, and drug. Okay, all in all 200. So this is the 199th element, it's drug, and this is the 200th element. Okay, then so okay, and then response. Okay, so this is also 200 numbers. The first 100 numbers has a mean of 25 and standard deviation of 5. The second has a mean of 23 and standard deviation of 5. All right. And then here we're creating a object, my data, and this my data is a data frame. See this code, guys? Data.frame, and it consists of ID, and we gave the ID a name, patient. Okay, so patient is equal to ID. So what will appear now in our data frame is not the title ID but patient, and then the treatment will be the variable name for the group. And then response, capital R, will be the name for the object response. Okay. All right. So let's run this. Let's run this first. Okay. So have I run response? Okay, I haven't run response. I'll run response. And then, okay, I will not run view group anymore. I'll run my data. Okay, my data. Okay, there. So we created an object, my data, and since we placed a parenthesis there, it automatically printed in the console. Okay, what can be found in my data. Okay, so let me just generate it in a tab here. So here, patient. Okay, that's the ID 1 to 200. And then we have here treatment. Okay, vehicle, and then drug. And then these are your randomly generated numbers. Okay. All right. And the names have been modified: patient, treatment, and response. Okay. All in all, 200 entries, 200 observations. Okay. So that's my data, the object that we created here, my data, 200 observations of 3 variables. Okay. So these are data frames. Okay. Any questions so far? Were you able to generate our output?
Yes, sir.
Okay, good.
Yes, sir.
Okay, thank you. Okay, so that's a data frame. Okay, so we can let's try to see what we can learn about data frame. Okay, let me increase the size of this. Let me close this. Okay, the head function, if you recall, guys, will give us the first 6 elements. Okay, there. First 6 elements of our object, of our data frame. Okay, so that's the head function, if you recall. Or if you want more rows, you can write head, my data, and then 15 rows. You can do this. It will generate the first 15 rows of our data frame. There, 15. Okay. Or the tail function gives us the last. The default is 6 elements, but here it's the last 12 elements of our data frame. Okay. Then dimension, what's the dimension of my data? You have 200 rows and 3 columns. This is the dimension of our object, my data. The length of my data is a number of here it's a number of columns, okay? And then the structure, okay, if you recall this, it's a data frame consisting of 200 observations of 3 variables. Okay, here we have, okay, my data. If we recall the $sign, it means it gives us the variable, okay? $patient, that's the variable patient. $treatment, that's the variable treatment, and $response, that's the variable response. Okay? And it gives us also the type of data. It's an integer for the patient, that's the ID. Character for treatment, and response is numeric. Okay, so that's what we get by structure. Okay, for the summary, what will be relevant here is only the quantitative variables. Okay, integer, character. The character will just give us the count. The response will give us the summary in terms of the minimum, first quartile, median, mean, third quartile, etc. Of course, guys, the 6-number summary for the patient or the ID is of no use actually, because these are just ID numbers. So we don't really get the mean of the ID numbers or the first quartile of the ID numbers. For the summary, what's relevant is the response. Okay, so the minimum is 12.18 and the maximum is 36.73. Okay, pause for a while, guys. Kindly chat or unmute yourselves. Are we okay so far?
Yes.
Okay, Robbie, welcome.
Hi, sir.
What time is it there in Chicago?
4
Oh,
4 a.m.
Okay. If you need to leave ahead, please go ahead. No problem. I know you're working there.
Thank you, sir.
Okay. So, and maybe it's very, very cold there now.
Yes.
Yeah. I think you're wearing 3 jackets or sweaters. So
2 layers, sir.
2 layers. Okay. Don't be ashamed to send to us via Zoom some cold air here. Okay. Because it's
Sure,
quite
sure.
hot here. Right, sister? Isn't it hot today?
Yes.
Yeah, it's quite hot and it's quite humid.
Yes. From yesterday.
Yeah, that's correct. So we'll request Robbie to send us some cool air.
Sana ko as you know.
Oh, okay. All right. So any questions so far, guys, about the data frame, about the nature of the data frame? Okay, the what it is, okay, what are the requirements for it to be considered as a data frame? Okay. All right. Chat. Okay. Hi, Robbie. Good morning. Okay. All right. So moving on, guys. Okay. Now, for data frames, we can subset them. When we say subset, we can get elements from the data frame, not the whole data frame, not the whole object, but also parts of the data frame. So remember our object is my data. By using my data, and then here you have brackets, okay? Brackets 1, 2. The first number here is your row. The second number is your column. So here we're saying, give me the first row and the second column of the object my data. If we take a look at my data, okay. So this is the first row, okay, this one, and this is the second column. So that is vehicle, okay. So that object is vehicle. So let's run that. So this one, my data 1, 2, okay. Here, guys, here. You can see that it gives us vehicle. That's the first row and second column. Okay, how about second row and third column? It will give us the number 27.24, 24, okay? So that's the second row and third column, 1, 2, 3, 27.24. Okay, so that's how we can generate a subset of your data frame. Okay, you can, of course, subset several rows and several columns. Here, you want to generate the first 20 rows and the second and the third column. So let's do that. Okay, so there you go. Okay, let's see. Okay, here. This is the first 20 rows, 1 to 20, right? And the second and the third column, treatment and response. It did not include the ID. Okay. And of course, you can also just generate the first, here, we're generating the first 20 rows, okay? It's empty here, it means everything. You're not making any distinction. If you leave it blank, it means everything as far as the column is concerned. Let's run it. Okay, so here you have, okay, all the columns. The first 20 rows, okay, and all the columns. So that's how we subset our data, okay? Okay, this one, guys, there are similar subsets. So what does this give us? My data, this gives us all the rows, okay, and the third column. We're not putting here any number, and it indicates that it should be all the rows and just the third column. So let's run this. There. The third column is the response, right? Okay, so only the third column, the responses there. It did not give us the first and the second column, and it gave us 200 rows. Okay, this is the same, guys. This one is the same as this one. My data, then all the rows, and then response, because response is part of our my data. Okay, say my data and give me the response or the third column, same as this one, my data $response. So all of these guys will generate the same elements. Okay, so if you try to run that, guys, this one, it will give us the same element as the first one here. And my data $response will give us the same element, the same output. Okay, any questions as far as these three codes are as far as these three codes are concerned? Any questions?
No, sir, for me.
Okay, thank you. Thank you.
And so far, sir.
Okay, thank you. All right, let's have other examples. Okay, for this one, my data. Okay, so this again is the first item here is the row. Okay, it's the row, and it's telling us that, what's this? As far as the row is concerned, we look at the response, okay, right, and we give us what will be given, guys. Only those whose response are greater than 26, and give us all the columns. Okay, do you get this, guys? We will be given all the columns, but only those those rows whose response is greater than 26. So let's run this and let's see what happens. Okay, so as far as the rows is concerned, 34, 27, okay. All right, so you can see here that, okay, for all the rows, okay, the responses are all greater than 26. Right, guys? And it gave us all the three columns. Okay, any questions about this, class? Of course, if you want to create another object out of this, you can, for example, right here, let's say sump1, So it will create an object, which is also a vector. Samp1, I just named it sample1, samp1. Okay, and run this, control enter. Okay, now we have, okay, now I have an object called samp1. Okay, and it contains 62 observations of 3 variables. So let me run this. Okay, here, 62 entries, 62 observations. Okay, and these are, it consists of also of the 3 elements, 3 variables: patient, treatment, response. And you will notice that here all the response time is greater than 26. Okay, we created an object out of that okay, subset from my data. Okay, now let's take a look at this. What does this mean? My data. Okay, so for the row, okay, remember guys, when we subset, the first thing that's identified here is the row. The second is a column. So we know that for the columns include everything, but for the rows we'll have some restrictions. So we're telling R to generate. Okay, maybe let's put this as an object, samp2 alt minus. Okay. So what does this object contain? It contains, from the my data object, we subset the treatment should be equal to vehicle. Okay, and the response should be less than or equal to 23. Okay, take note guys that, okay, take note that that's the reason why we would prefer using double equal to, okay, equal to for your assignment. Sorry, we would prefer using the assignment operator instead of equal to, because sometimes we might use the equal to or double equal to in our code, and that could cause confusion. Okay, so what's the meaning of end here? What's the meaning of end? Okay, as distinguished from this. Okay, we'll see guys what this means, and we'll try to differentiate that with this one. Okay, because there's a difference between and or. Okay, so here we're creating an object called samp2, and we're subsetting from the object my data. Okay, and we're saying that the treatment should be vehicle and the data response should be 23. Okay, so let's run this. So here I have 34 observations of 3 variables. Okay, the treatment should be vehicle and the response should be greater than 23. Let's run this. Okay, vehicle. Okay, so there are 34 observations, and your treatment, what happened to our treatment? It's only those that are vehicle, and the response time only include those that are less than 23. So both conditions have to be met. Okay, so that's the meaning of end. Okay, this one, the end here means that both conditions have to be met. So it should be both vehicle and the response should be less than or equal to 23, as seen in our samp2 object. Okay, all of these are vehicles. There are no drugs here. Okay, and the response time also are all less than 23. Okay, if we take a look at our original data, okay, let's take a look at our original data. So patient number 1, okay, will it be part of the samp2? This one, will it be part of samp2? This is vehicle, but the response time is not less than 23, right? So this should not be part of our samp2. Let's see. Okay, so there you go, guys. Okay, patient number 1 is not part. Okay. Okay, let's take a look again at, let's go back to my data. Patient number 2 is also not part of sample 2 because this is not less than 23. Patient number 3, it's vehicle, and then it's less than, the response time is less than 23. So this should be part of your sample 2. In fact, it should be the first one. And if you check sum 2 class, so yeah, it's number 3. It's correct. Okay, so let me pause for a while. Any questions? Are we clear so far? Kindly chat if it's clear. Okay, thank you. Okay, how about sister and how about Ronnie?
Yes, sir.
Thank you.
Yes, sir.
Thank you. Okay, thank you so much. Okay. All right. So how is my pace, guys? Am I going too slow? Kindly feedback. If I'm going too slow, then I'll hasten the pace a bit, or we're just okay with our pace. Hello? Would you like to comment, guys, on our pace? Because I want your feedback is very important for me. I can accelerate the pace a bit, or I'll just maintain the pace if you think that that pace is just fine. For the next sessions, guys, I'm going to give you in advance the code so that you can work on it ahead of time. So that when we study it in class, okay, we'll be able. Okay, Robbie, thank you. Maintain the pace. Thank you. Thank you, love. How about sister and Ronnie?
Yes, sir.
Yes, sir. Increase the pace. Sister,
Yes.
increase.
Yes, po.
Sure. I'll accelerate the pace.
Maintenance.
Maintain. Okay. Maintain. Ronnie, are you okay with the pace? Do you find it slow or just fine?
I do it. Not find it.
Sorry. Am I going too fast or just fine?
Fast. Fun.
Fast.
Fun. Not fast.
So just fine.
But just fine.
Okay. Thank you guys for the feedback. Okay. All right. For the next one, let's see the difference between this operator, the OR. This is the OR operator. Okay. OR. Okay. As against the AND operator. The AND operator is this one. Okay. And the OR operator is this one. Okay. Okay. This is the OR operator. This is the AND operator. So here, guys, AND, okay, and OR. Okay, what's the difference between the AND and OR? The AND operator, both conditions have to be met. For the OR operator, at least one of them has to be met. Okay, so let's take a look at this. My data. Let's call this sample 3. Let me use a small letter, sum3. And what are we required? We're told that it should be vehicles or, okay, greater than or equal to 21. Okay, let's see. Before we run this, let's try it ourselves. Let's see if we'll get the correct answer if we were the ones to classify this, to subset this. Okay. Vehicle or greater than equal to 21. Okay, let's see, guys. Will this be part? Okay. The first one, will it be included in our sum 3? Okay, yes or no, guys?
Yes, sir.
Okay, yes. Okay, you're correct. Yes. So all the vehicles will be part. Okay. All the 100 vehicles will be part because that's one of the conditions. Okay. And it doesn't matter, guys, if the other condition is not met. Okay, because it's an OR condition. For as long as it's a vehicle, then okay. Okay, what will come next, guys, is the drug. Okay, so the first 100 will be part of sample 3. However, the next one, let's see, drug and 19. Will this be part of the of sum 3? Drug and 19.5. Will that be part? Yes or no, guys? Our code is greater than or equal to 21 and vehicle. Will that be part of the sample? This one, this observation number 101, ID number 101.
Yes, sir. Less than 21.
But the condition is greater than or equal to 21.
Sorry, greater than. No,
Yeah.
sir.
So it won't be part, right? It won't be included. Am I correct, guys? It will not be included because you take a look at both conditions. Drug, okay, it does not meet the criteria. 19.52 does not meet the criteria also. So both criteria were not met. Okay, so going down, both here not met. ID number 102, ID number 103 not met. How about ID number 104? Was it met? Yes, the response time was met. This is greater than 23. Okay, so this observation, ID number 104 will be included in our sample 3. Okay, so let's run that. Vehicle or response time should be greater than or equal to 21. Okay, let's run this. And so we have this object sum 3. There are 169 observations all in all. Okay, and then if we access this there. So notice the first 100 elements which are vehicle are included, right? And then true enough, guys, we said 101, 102, 103 were not included, but 104 is. It's included. Okay, if you check the response, all the responses should be greater than or equal to 21. There will be nothing there that will be included that's less than 21. Okay. All right. How about this next one? What does this mean? Exclamation point equal to. Anyone? What does that mean? Exclamation point equal to. That means, guys, let me write that. That means that means not equal to. Okay, exclamation is equal to. It's a negation of equal to. It means not equal to. So here, let's call this sum 3. Sum 3. Okay, here it's from my data, the treatment variable for the row, guys, for the row. Okay, everything, anything that's not vehicle. So which means it should be all the drug treatments will be included, or my data response should be 24. Okay, so anything that's drug for the treatment will be included, but if it's vehicle, it should be greater than 24. Okay, so let's run this. Sum number. Okay, so what was my mistake here? Did I miss out anything here? Sum 3, my data error in or not found. Sum 3, my data, okay, not vehicle, okay, and then so that means all the drug, and then my data response greater than 24. Do you see my error here, guys? Do you see our error? Object or not found. Treatment. Did I misspell anything here? Okay, let me, what happened guys when you run it? Okay, I'm sorry. I think this was the one that ran, the note that I wrote here a while ago. Okay, so I now have sum 3. Do you have sum 3 also, guys? Do you have sample 3 also? Hello? Were you able to run sum 3? Hello?
I think need because we need some another name sample 4.
Ah, wait. Ah, yes, I'm sorry. It overwrote.
Because
Yeah,
because
okay.
different.
So what happened, guys, was that sum 3. So I lost already my sum 3 here. Okay, it's okay if you don't name. Yeah, I should have named it sum 4. Okay, so let me just run sum 3 again here. Okay, we had 169 observations there, and then I'll name this sum 4. Okay, which has 162 observations there. Okay, if I run sum 4, okay, so what did we say here? Sum versus sum 4. So this is, okay, my data treatment not equal to vehicle, okay, and then greater than 24. Okay, let's take a look at this. Okay, so it should include, guys, it should include all the drugs. Okay, all the response that are under drugs. So if you take a look from drugs from 101 up to 200, okay, up to 200, everything is included. Okay. There, right, guys? Because it says there, not vehicle. So if it's not vehicle, then it means it's drug. So all the drug responses were included. However, will there be responses equal to vehicle that will be included? Yes. What will those be? Those that are greater than 24. There. So those with vehicle are included if the response is greater than 24. But for drug, it doesn't matter. Okay? It doesn't matter. See, drug here, drug, it's 15 only. It's less than 24. It doesn't matter because it satisfies the other condition. Okay, the other condition that it should not be vehicle. Okay, clear, guys? Clear? Are we clear so far?
Yes, sir.
Yes,
Okay.
sir.
Okay, good. It's very easy, right? So far. But I'm afraid because you might be talking about it among yourselves. Oh, our lesson in our masters in Fin 601, it's so simple. Why is our teacher teaching us so many simple things? Sister, you messaged me yesterday, and you told me that why are you teaching us very simple things?
Wow.
This is
Sister, you are telling me that these lessons are so simple.
no.
Just joking, sister. Just joking. Okay, so let's name this sum 5 just to distinguish it from the other samples. Again, this is equal to drug. So all the drug items should be included. All those with treatment equal to drug will be included, and those with response that are greater than 24 will be included. Okay, so it will be the same, guys, as sum 5, right? Sum 4. So sample 5 will be the same as sample 4. Agree, guys? Will sample 4 and sample 5 be the same, exactly the same?
No.
Okay. What does not equal to vehicle mean? This one.
This vehicle not include this formula only for the drug.
Yeah. So how about this?
Oh,
Right?
this is equal.
Yeah. So not equal to vehicle is just the same as equal to drug, right? So we have two types of treatment. We have vehicle and drug. So we're saying here that it should not be equal to vehicle. If it's not equal to vehicle, then it should be equal to drug. Okay, because we only have two responses. And then here, response is, treatment, sorry. And then here, response is greater than 20 for the same one here in sample 4. Okay, so let's run this. Okay, it will be the same exactly as sample 4. Also 162 observations.
Yes,
All the drug will be included, but only those for the vehicle, treatment vehicle, only those that are greater than 24. Okay, there, exactly the same. If we run this, okay, so all vehicle will be included if and only if it's greater than 24, and all the treatment drug will be included. Okay, so see, 101 up to 200, ID number 200 will be included since they're all, the treatment is drug. Okay, so we have learned how to subset, because we're going to meet this in the course of this subject. There will be many data frames that we will be working on, and then we will be subsetting them. Okay, here we're creating an object. Okay, this I think this is another example. Okay, we have here another object, age. Okay, age, and it's again we're rounding off. Okay, our norm 200 objects, also 200 observations. Mean is equal to 40. Standard deviation is equal to 20. Let's run this. Run. Okay, so we have here age. It's rounded off. Let me put here the reverse age.
excuse me, sir. In our
Yes.
sum 5, so error unexpected. I don't know what happened.
Where?
In sample 5. What happened?
Were you able to run the age
No,
object
not before.
before?
The same 5.
Sum 5, okay.
Yes.
Did you encounter an error?
Error unexpected.
Okay, let me see.
Yes.
Why don't I make everyone as co-host? How do I do that? So that if you will share your screen
Yes.
more, okay. How do I make everyone my co-host? Where is that? How do I make everyone a co-host? Also coding. Where do you find the making everyone a co-host? Okay, make co-host. Okay. Okay. Also, let me do that for the others also. Make co-host. So that you can share your screen anytime. Okay. So sister, let me stop share, and could you kindly share your screen, please?
This one.
Okay, unexpected. So where's that? Sample 5. Okay, my data. Okay, my data dollar treatment is equal to drug. My data response greater than 24. Sum 5. Looks okay. Error unexpected in bracket. Could you run that again, please, sister?
Yes.
Could you run that again? That's sample five.
Yeah, now it's okay.
That's there. Yeah.
Thank you. What happened?
Why do you have 166 observations? I only have 162.
Yeah, this is
Okay.
different with
Yeah. I'm sorry, guys. I'm sorry because we have different numbers, right?
yes.
I'm sorry. We'll have different answers because you have these are random numbers. Okay. All right. So okay, na sister.
Yes, sir.
Okay, sige. Okay, let me share the screen again. Okay, now what we're going to do now is create another object called age. Okay, so these are 200 observations also. The mean is 40, the standard deviation is 20. Same thing, we'll have different answers, guys, because these are random numbers. Okay, so have you created your object age? Okay, I have my number here. I have my object age. Okay, 200 observations all in all. Okay, there. This is the 193rd. Okay, now I have a problem because why is this negative 19? Is this negative 19? So let me check. Age. Do I have a negative 19?
I have negative
No.
2.
Yeah. Okay. Because it's random numbers. Okay. So maybe let's just use. Okay, in order to avoid random numbers. Okay. So let's not use the R norm because that might create random numbers. Let's just use the run if, guys. Okay, so let's do this. Let's replace it by round run if. I'll copy this. Okay, let's copy it to replace. Let's replace the R norm. Run if there should be 200, and let's put the ages between 20 and let's say 75. Okay, there. So I'm creating 1, 1, 2, 3, 1, 2. I still have one more. 1, 2, 3, 1, 2, 3. We're creating 200 numbers. Okay, we're using the run if function. Okay, then it should be minimum of 20, maximum of 75. Okay, and round, no decimal place here, and we'll call the object as age. Okay, so control enter. Okay, there. These are our ages. Okay, running from 20 to 75, 200 of them. And then, guys, what we're going to do is we're appending. Okay, we're appending. Okay, we're creating an object in the my data dollar age. Okay, and then it's the object age. The name of the variable is capital A. Okay, capital A GE. Okay, and then the object is the age object, 200 numbers also. Okay, so let's do this. Let's run my data age. Okay, and then let me print the first 6 elements of my data there. Okay, we now have inserted a column age in our object my data. Okay, did you get the same, guys? Of course, not the same numbers. Okay, I'm sorry, a while ago, guys, I was giving an example. I was discussing an example, and you were using a different data set. I forgot to realize that we were using random numbers, so we had different responses. We have different answers. We should have set the seed, guys, to a certain number so that we have the same answer. Okay, again, also we'll have different answers here, but the ID should be the same, treatment should be the same, the response would be different, and the ages would be different. All right. Okay, guys, is your object, is our data frame my data? Take note, my data now consists of 200 observations with 4 variables. All right?
Yes, sir.
Okay, so let's continue. Okay, our objective is to be able to finish this tonight and move on to another to the major lessons that we need to discuss in this subject, which are more on the trading side. Okay, stocks. Okay, so we're creating an object here called X, and it consists of this 623, 2030, 2013, etc. So let's run this and see what's the classification of X is. Okay. So you notice that these elements, the ones with the quotes, will be treated as characters. Okay, they will not be treated as dates. Since they have quotations there, they will be treated as dates, as characters. Okay, so R will treat the vector X as characters. To make this dates, okay, we will have to coerce it as a date. Now we can use the package lubridate. Okay, may I request you to please run this, install the packages, lubridate. Okay, and then acquire it using the library. So I'll just run library. Okay, because I already have installed the lubridate. I'll give you a few some seconds to install the package.
Just run the package, sir, or run it under console.
Anywhere, it will be fine.
Not install.
So, yeah, you can highlight this too, and then Control Enter so that you first install the package and then afterwards run it, access it.
Done, sir.
Thank you. If you're done, kindly also inform me. Love, thank you.
Done, sir.
Okay.
Yeah.
Robbie, thank you, sister. How about Ronnie? Are you done?
Yeah.
Okay. Was that Robbie or Ronnie? Okay. So, all right. So here, guys, this is a query. Okay. So let me run that here. Question MDY. So that's month, day, and year. So notice here, let's run this MDY. Okay. So this is from the lubridate package, which we just run now. Okay. So the lubridate package allows us to work with dates. Okay. So you can transform, you can do things with dates. One of the trickiest in are dates. Okay. It transforms dates stored in character and numeric vectors to date or POSIX CT. So we'll meet this later on when we go to time series. Okay. These functions recognize arbitrary non-digit separators as well as no separators. Okay. So there are some examples here: YMD, YDM. Okay. So that's the format: MDY, month, date, year, month, year, date. You can specify the format for your date: DMY, DYM. Okay. All right, and maybe there are examples here. Okay, for example, this one, guys. Yeah, this is an example. X here, there is a vector here called X. Maybe let's copy this. Were you able to see this sample codes from Lubridate? What's good with the help functions in R is that usually there are examples that you can use to run that you can run and then learn more about the function. Okay, can you see this one, guys? Control C. Let's. Okay. Okay, what I'm going to do is, okay, let me. Okay, let me close this 1, 2, 3, and then it's insert another one. Let me insert another. Insert, and then I copy this. Okay, I copied this one. Okay, then this one has to have a beginning 1, 2, 3. Okay. Okay, so all right. So just again, just to summarize what I did, because you might have gotten lost because of what I did. So I asked some information about YMD here, or MDY, and then it brought me to this. Okay, this is from the Lubridate package documentation. Okay, so this tells us how to run some of the functions of this package, YMD, YDM, etc., different formats for dates. And then I copied the examples here. I inserted it here so that we can follow along. Okay, so here, okay, I'm creating this object X. Okay, what's X? Rx, if you recall, guys, Rx is these 3 character objects. Okay, these were treated as characters. But notice that they are in date format, but they are treated as characters. If you want them to be converted into dates, then we can make use of this package Lubridate. So here, because the format of the objects above, month, day, year. So this is MDY, month, day, year. Okay, so we create an object here called x.date. Okay, and it's MDY of object X. Okay, let's run this. Okay, so now it's notice that, okay, this x.date, guys, what is this? Okay, x.date contain these elements, and what is now this? Okay, so it's now a date. Okay, it's no longer a character. So we created this object called x.date, where this object X, which has the format M, month, day, year. So we said that this is the month, this is the day, this is the year, and R was able to convert it into a date. Okay, we asked what was the class of this object x.date, and it gave us this answer that it's a date. It's a date function. Okay. So I think this is almost the same, guys. Okay. So here, this is an object called, once again, X. Okay, and it contains this one. X. X is a character. X consists of 3 characters. If you want, so this is the 090101. Okay, we're telling R to convert this using the YMD date. We are going to convert this, okay, into, this is the year, this is the month, and this is the day. Okay, YMD. So that's what this means. YMD, the first one here is the year, the month, and the day. So let's run this. YMDX. So what is now our object X? Okay, YMDX. Okay, so let's see, class X. Oh, it's a character, YMDX. What happened here? YMDX. Okay, wait. I'm sorry. We haven't converted it yet. Huh? Okay, where are we? This should have converted our object. Okay, again. So X is a character variable. Okay, I know. Now I know. Sorry. Okay, YMDX. Okay. So this is now our X. Our class of X is character. Now, why wasn't it able to convert? Why wasn't it able to convert our X into a date object? Guys?
Sir, excuse me po. Na-DC lang daw po si Love.
Sorry.
Na-DC lang daw po si Love.
Okay.
Okay, sir. Mabalik na.
Okay, thank you, love. Okay, in a while, guys, we'll have a 5 to 10 minute break, okay? Water break. Okay, so let's just finish this, and then we'll have a break for you to breathe a bit. No? Okay, so now here, guys, we created this object 090101, 090102, and 090103. Okay, and we were telling R to convert this into a YMD. So we were using the YMD function of lubricate. Now, was it successful? Okay, it was not successful because it was not able to understand what this 090909 is. Okay, because it's year, month, date. Okay, so if I run this code, guys, by the way, I just inserted this. No? Okay, so what was the class of that object? It's still character. Okay, it's still character because, okay, the year has to be spelled out here. Okay, now let's do this. Let's create this object. I'll call it X1. Okay, X1. Okay, and then it consists of this 20090101. Okay, and then I'd like to convert it into a date object. Let's convert it into a date object. Okay, so I'm using YMD, okay, X1, and then let's see the class. Okay, let's see, Control Enter. And let's see. Wait, something's wrong here. It still did not convert. X1, okay. Let me see. So I think something's wrong with what I did. Okay, examples. Okay, I was using lubridates examples. I just copied this. Okay, it did not convert. It's still character. 20090102, 20090103. Okay. Why did it not convert? Okay. In your case, guys, did it convert? Did you copy this, the examples in duplicate? Okay, let me check this during the break. I'm going to check this, guys, why I was using the example of duplicate and it doesn't run when we perform it. Okay, but let's do the other one. Let's see. Here, what we copied is YMD 09 09 01 01. Okay, let's see if this will run. 0901 09 90102 90102. Let me see this. Let me call this X2. And then class X2. So I just copied this code, guys, this one, YMD here. And I created an object called X2 out of it. And let's see if this will. Okay, so it's a date, guys. X2 there, date. Okay. X1. Okay, so it was not able to convert X1 into a date. Okay, but this one, 09, 01, 01, we were using the year and then the month and then the day. Year, the month, then the day. It was able to convert it, okay? So I'll get back to this later on, guys. I'll just see what happened here because this was the example of lubricate, okay? And it doesn't seem to run. Okay, but this one run, this other example run, okay? And by the way, also the now function, if we write the now function, let me write it here now. Okay, so this gives us, okay, the now function will give us 2021, 11, 12, 19, 28. So this is CST. This is, I think this is Central Standard Time. CST, I'm not sure if CST is, let me check, guys. I'm not sure about CST. Central Standard Time or, okay, let me check later, guys, what CST means. I have a feeling that this maybe this could be China Standard Time because we have the same time zone as China, as Beijing. So I think this is China Standard Time, but let me check later, guys. Okay, so that's now. Okay, now greater than YMD 209. Okay, what does this give us, guys? So this gives us a logical statement. So it's telling us that now is now greater than YMD 2090101, and this should be true. Okay, yeah, this is true because today, which is November 12, is greater than okay, January 1 of 2009. Okay, so let's just finish this other lubricate functions. Okay, actually, guys, to be honest with you, dates are one of the trickiest data type to handle in R. Okay, that's why later on we're going to, in the course of this subject, we're going to learn, maybe later, yeah, we're going to learn the XTS object, okay, which is really more powerful. Okay, I'm happy that they invented that object, XTS object, because it makes dealing with the day and time a lot easier. Before, it's really quite difficult today to deal with dates. Okay, as objects in R. Okay, let's do this. So here we're creating an object called B day. Okay, so this is day, month, year, 14, 10, 1970, 1979. So let's run this. Okay, so B day here. Okay, 1979, 10, 14. Okay, so what's B day? Let's see, class B day. Yeah, it's a date. Okay, it's a date. So we were able to create this object b day, and then it's the class type. Okay, it's a date. Okay, then we can ask what's the month of the b day. So the month is 10, right? Because this is date, month, and year. Okay, M is the month, so that's October. And also we can say weekday. Okay, this is the function weekday. We're asking for the weekday of the birthday, and then we're saying that give it a label. Label is equal to 2. Let's run this. Okay. So we take a look at this code, guys. Weekday of the birthday. What's the birthday? What date is that? The date is October 14, 1979. And it tells us that, okay, it's a Sunday. October 14, 1979. That was a Sunday. Okay. So as an exercise, guys, you can write your birthday there, and you can identify on what day you were born. Okay. What day you were born. Okay. So this one is year of the birthday. So what are we doing here? We are changing the year of the birthday because the year here is 1979. Here we're writing this code. The year of the birthday should be 2016. So let's do that. Okay, so we changed the year of the object birthday. It was 1979. Okay, but take a look now at the object birthday here. It's now 2016 because we replaced it. Okay, so let's see weekday. Okay, so the October 14, 2016 birthday fell on a Friday. Okay. It fell on a Friday. And also, guys, we can also here YMD 2010, 12, 15. Okay. So this is year, month, day. Okay. YDM is year, day, month. MDY, HMS will add R's. Okay. Okay. YDM is year, day, month. MDY, HMS will add the R's, the months, and the seconds. Okay. So any questions so far, guys? Any questions as far as your data frame is concerned and your date object? Clear so far? Okay, I think I know where my mistake here was. Where are the example here? Examples. Okay, so this was teaching us how not to. Okay. Let's see the YMD. The dots here, a character or numeric vector of suspected dates. Character vector. So that should be fine. MYD, so this is the vector. Values without displacing customer. All right. Maybe I'll look at this first. Okay, so let's see, guys. And are there any questions? Okay, no questions. All right. So let's have a how many minutes break, guys? How many minutes do you want? Hello?
Follow.
Sorry, how many?
Just follow 10 of this.
Okay, 10 minutes, guys. Okay, let's have a 10-minute break. And when we come back, guys, we're going to finish this, the fourth data structure type that we have. Okay, thank you, love. Let's have 10-minute break. We're going to finish this. Okay, matrices. And then we go to the next slide where we're going to learn the package quant mode. Okay, 7:37. Let's resume at 7:47. See you in a while, guys. Thank you.
Yes.
Thank you.
Thank you. The last data structure that we're going to look at are matrices. Now, in your previews, maybe in subjects in college or in elementary, you met matrices. And have you experienced doing matrix operations like adding matrices or multiplying matrices? Okay, I hope you have done it, but we're going to do it in R. Okay, so matrices are just like data frames. They're two-dimensional. You have rows and columns. The difference between data frames and the matrices is that data frames can contain different types of data, while matrices are strictly for numbers. Okay, so the code for matrix in R is matrix, and then identify the data, number of rows and number of columns, and then define if it's by row or by column. Okay, the default is that the data is filled up by column. Okay, so let's have an example. Okay, we're creating an object called A, and then we're converting it into a matrix. Okay, the elements are 2, 3, -2, 1, 2, 2. Okay, so this is your data. Okay, it's a combination of these numbers 2, 3, -2, 1, 2, 2. And then you identify the rows, the number of rows, and the number of columns. So here we're saying it's 3 rows and 2 columns. Let's check. There should be 6 elements here because 3 by 2 should be 6. 1, 2, 3, 4, 5, 6. Okay, that's okay. And then here we're not saying whether it's by row or by column. So since we're not saying if it's by row or by column, then the default will be by column, which means that the matrix will be filled up first by column. So let's run this. Okay, there. Okay, so you notice, guys, that it printed out the matrix A. Okay, 2, 3, -2, 1, 2, 2. So how was the matrix filled up? By column. 2, 3, -2, 1, 2, 2. And you have three rows and 2 columns. Okay, so what's this, guys? What's this? This is a bracket. This is a subset, right? Take note, guys. Empty, which means all rows, right? And then the first column. Blank, comma 1 means all the rows and the first column. So this is all the rows and the first column. This is all the rows, empty here, and second column. This is the second column, right? This one, row 1 and all the columns. So that's this one. This is the second row and all the columns. It's this one. Third row, comma, empty, which means all the columns. So that's -2 and 2. Okay, so you notice how was the matrix filled up? It was filled up by going through columns. Okay, but we identified that it should be a 3 by 2. Okay, here is another object, A10. Let's run this. Okay, this time it's a 2 by 3 matrix. 2 rows, 1, 2, and 3 columns. 1, 2, 3. And how was it filled up? Again, by columns. So 2, 3, -2, 1, 2, 2. Okay? So this is a matrix, guys, and the syntax is define the data, define how many rows, define how many columns, and then if you want it to be generated by rows, then you say by row is equal to 2. So maybe let's do that. I think I did that here. Okay, let's do that here, guys. Let's identify this object. Let's copy this. Control C, Control V. Okay, let's call it 820. Okay, 820, same. Okay, and then let's do this by row, okay, is equal to true. So when we include this by row is equal to 2, it will now fill in the matrix by rows. Okay, so let's run this. Okay, so 820, you notice. So the elements are 2, 3, negative 2, 1, 2, 2. So 2 and then 3, negative 2, and then 1, 2, and then 2. So it's now filling up the matrix by rows. Okay. So notice how the matrix was filled up. 2, 3, negative 2, 1, 2, 2, 2, and then 3, negative 2, and then 1, and then 2, and then 2. A while ago, without us putting by row is equal to 2, the default will be by column. It will fill it up downwards. And since we said that it should be by row is equal to 2, it filled it up, okay, from left to right. Okay, clear so far, guys? Clear so far? If you want to generate a matrix, you use this function matrix. And then you identify the data, then the number of rows, and then the number of columns. Questions? Clear so far? Kindly respond, please.
Here so far, sir.
Okay, thank
Yes,
you.
sir.
All right, thank you. Thank you so much. Okay, so we're going to ask R if A is a matrix. So let's run this. Is matrix, then true. Okay, is A a vector? Okay, false. So it's not a vector, it's a matrix. Okay. Okay, dimension A will be the number of rows and columns, 3 rows and 2 columns. Okay. So these are some of the operations in matrices. Okay. Here you have multiplication by a scalar quantity. So let's identify C to be equal to the number 3. And then we can perform C times A. Okay, so let's run this. C times A, what happened to the matrix A? Take note, matrix A is a matrix. So you just multiplied every element in matrix A with the number 3. Okay, so that's very easy. Multiplication by scalar. Then we have matrix addition and subtraction. Okay, if you recall in your basic math, matrices can only be added or subtracted if they have the same size. Okay. So here, we're creating another matrix. What are the elements of matrix B? Okay, it's these are the elements, and 3 rows and 2 columns. So it has the same size as matrix A. Okay, so 2 matrices that have the same size can be multiplied or subtracted. So let's run B. Okay, so this is matrix B there. Okay, and then C. We generate C, which is just adding A and B. Okay, there. C. Okay, how did we generate C? C was generated by adding A and B. Okay, you can check that. So where's our A? Our A is 2, 3, negative 2. If we just add 2 plus 1, 3 plus 4, okay? So you can check that, guys, that matrix C is actually adding the elements, the corresponding elements of matrix A and matrix B. Same thing with matrix D, which is just the difference, you A minus B. Okay? All right, so any questions so far, guys? Okay, so I think that's very self-explanatory, adding matrices. and subtracting matrices. Now, what's tricky is matrix multiplication. From your basic math, you learned that when you multiply matrices, there's a rule to follow. Okay, you just don't multiply matrices. Okay, when you multiply matrices, okay, the rule is that, so let's define here a matrix F. Matrix F has a dimension of 2 rows and 3 columns, and matrix E has a dimension of 3 rows and 2 columns. Okay, now these matrices are multiplicable. Okay, you can multiply F times E. Okay, why do I know that matrix F times E is multiplicable? Anyone who remembered the rules in matrix multiplication? Anyone? Did you remember the rules in matrix multiplication? Hello? Are you still here? Okay. So let me highlight this. So I'll just briefly have a brief review of the rules of matrix multiplication. In case you forgot. Okay, sorry about that. I was trying to access my digital pen. Okay. Okay, just a quick review, guys, of matrix multiplication. 2 matrices. Let's see, 2, 1, 3, 2, 2 by 3, 3, 1. Okay, so you have this matrix. Okay, let's call this matrix F. And the dimension is 3 rows by 2 columns. You always define your matrix usually in capital letters. Okay, and then you define the size 3 by 2. Okay, you can only multiply a matrix, 2 matrices if, okay, so this one is, say, 1, 2, 0, 0, 1. The size of the dimension of matrix E is 2 by 4. Okay, can we multiply F by E? F by E? F times E, yes. Why? Because the column of the first matrix should be the same as the row of the second matrix. Okay, 2, they're the same. So the dimension of F times E will be 3 by 4. Where did we get 3 by 4? 3 by 4. Okay, so FE is multiplicable. We can multiply matrix F by matrix E. However, matrix multiplication is not commutative. So is E times F possible? Okay, given the same matrix, can we multiply matrix E and matrix F? The answer is no. Okay, because matrix E is 2 by 4. Matrix F is 3 by 4. Okay, since the column of the first matrix is not the same as the row of the second matrix, okay, therefore E times F, F is not multiplicable. Okay, we cannot multiply them. Okay, so that's the very basic rule as far as matrix multiplication is concerned. So let's go back to our matrix. Okay, very quickly. Okay, so here's the rule, guys. F times E. Okay, it's possible because the column of the first matrix is the same as the row of the second matrix. So order is very important. Okay, unlike algebra, guys, where our 3 times 2 or 10 times 3 is just the same as as 3 times 10. Okay. All right, here the size is 3 by 2. Okay, can we multiply it with F? Yes, because F is 2 by 3, but the resulting matrix are different. E times F will have a size equal to 3 by 3, while F times E will have a size 2 by 2. Okay, is that clear, guys?
Yes, sir.
Have you met matrix multiplication before in your college or in your elementary? Have you, guys? Silence means
So forgot.
forgot, but you did have or none. Okay, anyway, so anyway, we're just introducing this because later when we go to regression as a type of machine learning, we might be needing some matrix operations. Okay, so here we're creating these two objects, okay, E and F, okay, E and F has this element 2, 3, negative 2, 1, 2, 3 rows and 2 columns, and E is this one, okay. So let's run these two. Okay, so we have here matrix E and matrix F. Okay, matrix E is 3 by 2, matrix F is 2 by 3, then are they multiplicable? Can we multiply E times F? Yes, we can multiply E times F. Okay, so here, and matrix multiplication in R is denoted by this one, percentage and then times percentage. That's how we perform matrix operations. Okay, so F times E, okay, let's do that, and that's matrix G. Okay, and then also matrix H is E times F. Okay, that's also possible. Okay, I'm not going to the details of this. I would that you just review a bit your matrix multiplication. Okay. All right. So maybe some more here. Okay, a little more here. Okay. How about the transpose of a matrix? This one. Okay, if you recall, what's matrix A? Here. Matrix A, let's access matrix A. Okay, this is matrix A, okay? 2, 3, negative 2, 1, 2, 2. Okay, that's matrix A. Now we can get the transpose of matrix A, okay? Okay, what happened with matrix A? Okay, to get the transpose of a matrix, we convert the rows into columns and columns into rows. Okay, so this is matrix A, 2, 3, negative 2 going down. Now it has become 2, 3, negative 2 going to the right. Okay, so that's what the transpose mean. No? Just change the order. Just change. You make the rows as columns and columns as rows. Okay. Okay, so here we have a unit vector. When you say unit vector, so we're creating an object called U, the matrix, and we have remember these are data, and then 3 rows and then 1 column. So let's generate this. Okay, that's a unit vector. 3 rows, okay, 1 column, all number 1. That's a unit vector. Unit vector, which is actually a matrix. Okay. Okay, so we also have a 0. So 0 element, 3 rows and 1 column. Let's run this. Okay, all zeros. All right, so same thing here. Okay, how about identity? An identity matrix, okay, here, you use the function diag, okay? So we're not using here, diag means diagonal. Okay, so let's run this. Okay, an identity matrix is a matrix where your diagonals are all 1 and the rest of the elements are all 0. Okay, there. That's a diagonal matrix. That's an identity matrix, sorry. Okay, so we'll not go into the inverse of a matrix. I'll leave that to you guys for your review. Okay, and lastly here you have some exercise. Okay, I'd like to request you to work on this, to do this, okay, on your own. Okay, there are some questions there, and you may work on this. Okay, it uses the data empty cars from the package data. Okay, I leave this to you guys to work on as an exercise. Okay, so that wraps up, guys, our discussion on this as an introduction to R and R Studio. I hope that by this time you have gained some some comfort, some familiarity as far as using R and R Studio. All right, so may I request you to open the file that I shared with you? We're going to go into there now. Okay, so this is more what the subject really is all about. Okay, so in our canvas, I shared with you this file, Introduction to Quant Mode. Okay, may I request you to open it, and if you have opened it, please chat or please tell me that you're ready. Let me just close these objects. Okay, you have the file open already, class?
Yes, sir.
Okay, thank you.
Control.
Okay.
Yes, sir.
Okay, thank you. All right, so this is where really our classes begin, our lessons begin. Today we're going to look at using a very powerful package called Quant Mode. Okay, so may I request you to, okay, so you have to install these packages, tidyquant, Quant Mode, and TTR, and then kindly, okay, so kindly load it. Okay. Once you have loaded it, guys, kindly please inform me if you're done. Okay, let me load it also. I won't install it anymore because I have already installed that. If you're done, guys, kindly chat in the chat box or unmute yourself and say you're ready so that I know when to proceed.
Sir,
Yes.
is it that we run the whole chunk?
No,
for
no,
the-
no. No. Just load the package. Tidy quant, quant mode, and TTR.
I see.
Yeah. Only this one, guys. Only this one. Tidy quant, quant mode, and technical trading in R.
I mean, do we have to install the package?
Install it first and then access it through the library function or require function.
Need to restart. This is until need time.
Sorry, sister.
Sir, this is need to restart.
Need to restart? Why?
Yes.
Could you show your screen,
R
please?
Studio can restart R before installing the request packages.
Oh, really? Could you kindly share your screen, please?
Yes, po. This one.
One or more of the packages to be updated are currently loaded. Restarting R is highly recommended. Can we start before installing? It's okay. Anyway, it says that all work and data will be preserved during the restart, and it won't take long. It's okay.
Yes, po.
Yes. Okay. So you can do that.
Really?
Yeah.
And so I lost contact.
You don't believe me, sister?
But need time, I think.
Yeah, you can because it says they're all. I've experienced that several times already. It's okay.
It's okay?
Yeah.
Oh, thank you.
Okay.
Thank you.
If it doesn't work out, don't blame me. Okay. How about the rest? Were you able to access already tidy quant, quant mode, and TTR? But the focus of our discussion will be more on quant mode today. Robbie, were you able to load already the three packages?
quantmod is installing, sir.
Okay, thank you. How about Ronnie?
Yes, I already assessed that.
You're done? Wow, you're very fast.
Huh?
You're very fast. Love, were you able to load already the three packages?
Still loading, sir.
Okay, thank you. Okay, just inform me, guys, if you have loaded the packages, so that we can proceed with our discussion. Thank you, Rob. Rob is done. So Ronnie is also done. So let's wait for Sister and for Love to be able to access the three packages.
Can I share again, sir?
Yes, sure. Go ahead, Sister. Okay. Am I? Okay, kindly share, please, Sister.
Wait, this one, but not really restore. This one.
Okay.
It's okay.
Yeah. So where's your file? Okay. So yeah, it's okay.
Okay.
That's okay. Okay. You can close that.
Uh-huh.
Yeah. So you're okay. All right. Okay. So have you run the library
Run library. This
there?
one.
Yeah, that one. You run that chunk, that whole chunk. The one on the upper right, the one with the green.
The green
Sister,
one.
go to the right. Go to the right.
Yes.
Go down. Go down. Go down. Go
Yes.
down. No, down. There. Up. That one. But up. Yeah, that one. That will
Yes.
run the whole chunk. Yes. Okay, loading. Okay, you're ready. Okay. How about
Ready?
Love?
Okay. Thank you.
Okay. Love, have you?
Hold on, sir.
Okay, it's okay.
Because I've initially run the package, the
Okay.
whole chunk for the install package, and it's taking a while to load.
Okay. Sige lang. Okay. That's why sometimes, guys, when I run packages, I don't run the whole chunk. I run it one at a time. Because sometimes it slows it down. So from my experience, I normally don't run all the packages at the same time. I run it one at a time.
I'll just restart, sir.
Okay. It's okay. Escape mo kaya, no, Love. So while Love is restarting, okay, I can, okay. Here in the help packages, guys, in the help window, in the files window, you can, for example, you can run here quant mode. Okay, quant mode. Okay, here. It will give us some documentation.
Share with your share screen, sir.
Sorry. Okay, sorry. My screen is not yet shared. Okay, so while Love is installing, okay, there are different ways to acquire or access the package. If you have already installed, since you have already installed quantmod PTR and tidyquant, next time you don't have to install those packages again, since it's already installed. So if you want to access this, instead of running library, for example, library quantmod, tidyquant or quantmod, you can go here, packages, okay, packages. Okay, it's loading. We'll have different packages because I've already installed several packages here. So you cannot compare what's installed in my machine as far as the packages is concerned. Okay, it's still running. And then in your case, guys, you can type your quant mode. Okay. So still running. Okay. Okay. Thank you, Love. Love is ready. Is ready. Okay, maybe let me just exit this. Okay, there. Packages. Okay. So here you can type Q. Okay, and then it will generate the packages that are start with Q. Okay. In my case, it's QGraph, QPDF, QuadProg, Quandel. Here's Quant Mode. Okay, and the version that I have here is 0.4.18. So I can click this. Okay, click this, and notice, guys, that when I click this, the command is written here in the console, library quant mode, and it just tells us where this is located in my computer. So it's the same, library quant mode. Okay, you can do that. Okay, so now that we have accessed these packages, so let's not mind the get working directory and set working directory. Okay, I have here some notes about the prices, the price of a security. Okay, I leave this to you guys to read. What it states here is that, okay, so this was coming from a, I can't remember where I got this information. Okay, so it distinguishes between the price of a security, okay, and the value of a security. Okay, I leave that to you guys to read. Okay, and some information about quant mode. Okay, so let's start with the first code in quant mode. Okay, the get symbols function. So you notice here that I'm putting here quant mode and then double quotes. I think I mentioned to you last time that this is just to identify that this function get symbols is coming from quant mode. Okay, and what's good about quant mode is that you're able to download stock prices. You don't have to go to Yahoo Finance itself. You'll be able to, from our studio, get the prices from Yahoo Finance using the quant mode package. So let's run this. Okay, run it. Okay, and then you have here an object. Okay, let's go down here. So what did we do here? Okay, we are saying that using the quant mode package, please get the symbols of the Apple data. AAPL is a ticker symbol for Apple. Okay, so we're downloading a single stock here. And you notice now that we have an object. Okay, was everyone able to download the AAPL object, which is an Apple object, the prices of Apple? Okay, so it indicates here that this is an XTS object. Okay, and we got stock prices from January 3, 2007 up to the latest, okay, November 11, 2021. Did you get this, guys? Feedback, please.
Not yet.
Not yet. Did you run this code already? The quant
Not
mode
yet, sir.
get symbols. Okay, kindly run this code. Okay,
Ready.
finish already, sister. Finish. You have this already. Okay, Ronnie, you have it already.
Yeah.
Okay, Rob.
Yes, sir.
Okay, Love. Were you able to download already the Apple data?
I'm getting an error, sir.
You're getting an
Can you share
error?
my screen?
Yeah, sure, please. Okay, I'll stop share.
Um, Sir, can I have access for sharing screen?
Wait, I
Maybe
think
because I got disconnected.
yes,
while-
a while ago. Yes. Okay. Sorry. Yeah. Sorry. Okay. Okay. Make co-host also. Yeah. All right. There. Thank you, Love.
Thank you, sir.
Okay. Okay. Oh, you're ahead, huh? Okay. Here, quant mode, get symbols, Apple. Okay. Error. Yeah. Let me see. Could you run? Could you close that again? Close that error term there. That one. Yes. Please close it. And then could you run again that code chunk? Yeah. Okay. So you're not able to access, you're not able to connect with Yahoo.
Yes.
Okay. But, were you able to run already? Yeah, you have already run. Wait, quant mode here above, download. Wait. Yeah, you have already run quant mode. So you have already accessed it. Okay, now I don't know why this is the case. It must
I
have,
just,
yeah, it must be something with the connection. Okay,
yeah.
so may I suggest, Love, that later on you retry this. Okay, maybe after you close the file, maybe later on after we have our session, you close the file. Anyway, this is recorded so you can follow along.
Yes,
Okay,
sir.
and so this is a problem that we're encountering. Could you? Why don't you run the next line, please? The next one.
This
Okay,
one,
there.
sir.
Yeah, run
Oh,
that. Yeah. Okay, so maybe it's really with the connection, because this one will load the other stock prices. Okay, so Love, in the meantime, since I think this has something to do with the connection, we can't really do something about it. So is it okay for you just to follow along first?
yes, sir. Yes, sir.
Okay, thank you, Love. Okay, so sorry about that. But the rest, guys, you were able to follow, you were able to download. So Apple should appear here. And when you click this, okay, so here's the data, guys. So you don't need to go to Yahoo Finance, because maybe before, when you download stock prices, especially US stock prices, you go to Yahoo Finance and you follow several steps before you download. Here in R, you can use quant mode, and automatically the default is you're given the stock prices. For this year, it starts from 2007. So it's 2021 now. So 2007, 2021. So it's around 15 years, no? 15 years of data. We're given 15 years of data. So next year, when you, in 2021, when you again run this code, it will start with 2008 this time. Okay, because I noticed that last year, it started with 2006. So it's giving us 15 years of data. Of course, you can modify that and get earlier stock prices. But let's just use this. Okay. So you notice, guys, that it gives us the opening prices of Apple, the highest price, the lowest price, the closing price, the volume, and the adjusted price. Okay. So very convenient way to access stock prices or financial data coming from Yahoo Finance, and there are other sites like Quandel, Fred, and Wanda, which we're going to look into also in the next meeting. Okay, so all right. Now this quantmod is really a very powerful package. In fact, you can get the other using again the get symbols. You can get the stock prices of other stocks uh, as many as you want. Just be sure that you know the ticker symbol. These are the ticker symbols. These are like the ID classifications of these companies in the stock exchange. Okay, so let's run this. Okay, and then I will now have here, see, Amazon, Google, IBM, Tesla, and Netflix. So these are now objects that have been, okay, objects that are now loaded also in my R. Okay, they're Netflix, okay, Tesla, okay. We have IBM, I have Google, and then I have IBM, all those objects. Okay, and notice, guys, that these objects. Let me go to Apple. These are XTS objects. XTS. What are XTS? These are extensible time series. Okay, let me write that here. Extensible time series. Okay, these are types of objects called extensible time series. Now, what's so peculiar? What's so different about this time series? Let's go to Apple. Okay, you notice, guys, what's so different about this data, XTS data, XTS object. So you have here the variable Apple opening price up to Apple adjusted price, and then you notice that the dates are not part of the data. The dates are the index. Okay. Unlike when you sometimes get the data from other sources, the date will be part of your data. Okay, so there will be a column here, date, and then you'll find it there. So that's a data frame. Okay. This one is an XTS object, extensible time series, and what's peculiar about this is that the dates are indexed. Okay, so that makes it very easy to navigate or to work with XTS objects. Okay, unlike data frames. Okay, when we speak of a time series, this is a time series object because the data is arranged chronologically according to time. Okay, the object that we did a while ago, okay, remember the employee, this one, employee data. Okay, if I access this employee data, this is not a time series. Okay, what type of data is this? Would you know? What type of data is this? Okay, this is what we call a cross-sectional data, while the other one is a time series. Okay, this is cross-sectional data. Okay, you have this data. Okay, taken at this is a snapshot of the data now. Okay, this means that the employee data, employee name, salary, start date. This is like a snapshot of this data at a particular point in time now. Okay, so this is a cross-sectional data, while Apple here is a time series. Okay, so let's continue with our discussion. Okay. So we have done this actually, view Apple. It will, as you know, view Apple will just give us and show us this object. Okay. And then what's good about, and you can also, let's run also view the different stocks. Okay. So we'll have here. Okay. So here, guys, we put together view Amazon, Google, IBM, Tesla, Netflix. But that's not a good way to do it because what happened here was it combined. Okay, so first Amazon up to 2021. Okay, and then this is quite difficult to navigate through. Take note, guys, that there are 17,837 rows. In Apple, there was only 3,743. So what R did here was to put them one on top of the other. So first you have Amazon, and then after Amazon data, it plays the Google data. Okay, so not a good way to access your data. This one, viewing. It would have been better, guys, if you just access the data one by one. Okay, so this is another set of data, GSPC. This is S&P 500. SPY is a ETF. This follows the GSP 5 S&P 500. Okay, so this will be part of your own assignment. I want you to see. Actually, I already wrote it here. Okay, I would have wanted you to research on this on your own. What's SPY? What's SSLY? What's JNK? Okay, what's CWI? So I want you to at least be familiar with this. Read on this. What are these? What are these ETFs? Exchange traded funds. Okay, so that's part of your assignment. Okay, but of course you have to get the symbols first. Okay, let's move down below. Okay. Okay, so this is a more complete way to run the code. Okay, so here we're creating an object called Apple1. It still gets symbols, Apple. SRC is source, is Yahoo. So although we don't identify this, we did not identify this before, but that's the default. Okay, there used to be before you could get prices from Google, but now that has been stopped. So we hope that Yahoo will not stop allowing people to get stock prices, historical stock prices from Yahoo Finance. So here you can identify from where, from when. A while ago, we did not put this, right? And the default was from 2007 January, the first trading date of January. And then from 2010 to here we placed 2021 January 1. Okay, periodicity means the frequency of your data. So this is daily, and then auto.assign is equal to false. I'll explain later on what this means, that this auto.assign. And then view Apple1. So let's run this. Control Enter. So we now have this object AAPL1. Let me there, Apple1. This is also an XTS object. Okay, XTS object. Now here, a while ago when we downloaded AAPL, the default was from 2007. Here we specified we only want from January 2010, the first training. Although we wrote January 1, but what was given to us was January 4. Why January 4? Because that was the first trading date for 2010. Okay, and there are 2,769 entries vis-a-vis. Okay, let me close this. Vis-a-vis Apple 3743. So more entries for the AAPL XCS object, while here we only have 2769 because we limited the date, the period. Okay. So what's the difference here? This time, this is weekly. So one good thing about quant mode is that you can get daily data, you can get weekly data, you can get monthly data. So let's run this Apple 2. So here's Apple 2. Now there are only 574 entries. Okay. So here you have January 1, and then January 8. January 15, okay, January 15. So, okay, you now see that this is weekly data. Okay, so that's very, very convenient for us to access information via quant mode. Okay, clear so far, guys? Any feedback, please? Clear so far?
Still loading, sir.
Sorry, sister.
Still loading.
Still loading?
Yes po.
Okay, sige. Let's wait. How about Robbie?
Ako, sir.
Okay lang? Oh,
Opo, okay lang po.
you might need to leave. Anong oras dyan? You might have your work already.
Okay, sir. Thank you po.
Sige, just feel free to leave. Don't have to ask permission.
Thank you po.
Standing permission naman yan. I know that you will need to prepare already for your work, so you can just leave when you need to leave. Okay. Anyway, I'm posting this. Yung end naman, pwede mo nang panoodin at your own time. Okay.
Okay, sir. Thank you.
Okay, sige. Thank you. All right. How about Ronnie? Were you able to download Apple 1 and Apple 2?
Yes, sir. I just have Apple 1.
Sorry. You have what?
I just have Apple 1.
Apple 1. You can run Apple 2 now. Apple
Oh.
2, this is weekly data. The difference between Apple 1 and Apple 2 is that Apple 1 is daily data. Apple,
Sorry, I share my screen
yeah, sure.
because
let me
I can't find.
stop share.
Okay, I share. Try it. I just found the. Okay, share already.
Okay.
This is Apple 1, right?
Apple 1, yeah, 3743, yes.
Yeah, I think so. But where 87 cannot find Apple 2. I don't know where the documents.
Where's your file?
Yes. yeah.
I
This
think
is my question. I miss my failed.
This is not this is the one we were using a while ago. I think you close your
close. Okay.
you close your
maybe it's okay.
yeah. Open your file again, Ronnie.
Okay, I'll try again later.
Okay. I think you accidentally closed your file.
Maybe I'm not mention it. Close it.
Yeah. The file is class introduction to quant mode.
Because I found the 87 around. There is Apple. Okay.
Yeah. Sorry to hear that, Ronnie.
Okay.
Open your file again. Okay, open your file. Okay, so let me share. Sister, were you able to follow? Were you able to download?
Yes, but the rest of the loaded so very slow.
Were you able to download Apple 1?
Not yet.
Not yet. Oh, okay. Anyway, guys, if you're having problems with the internet connections, you can do this later. Okay, you can do this later. No problem. No problem at all.
This is still in GSP, SPY, SLY, and so.
Yes. So, can you see the screen now?
Yes, po.
Okay. So these are just repeats of what we did before. So we know, the head function, the tail function. The head function will just give us the first 10. The tail will give us the last, in this case, the last 10. Okay. Okay, so just check our data. And then here we have, here names. What does the names function give us? Names of Apple 1 will give us the names of our variables. So you have Apple open, Apple high, Apple low, Apple close. Okay. Now, by the way, guys, have you met this? Have you seen these variables before? Open, high, low, close, volume, and adjusted. Have you tried downloading prices in Yahoo Finance before?
Not in Yahoo Finance, sir. But I actually have account in one of the local brokerage firms, so I'm familiar with this and
Bloomberg?
No, sir. I mean, specifically for local markets lang, sir.
Okay. All right. Okay. Thank you, love. How about sister? Have you downloaded stock prices from Yahoo Finance before?
Sometimes Bloomberg, sometimes Yahoo, but not.
Wow. You have Bloomberg. Wow.
But just only find the data. Only find the data for the evaluation.
Sister, you're very social, huh? You're using Bloomberg.
Just to find the data.
Yeah. Yeah. Bloomberg has tons of data. Very, really very complete. Okay, so you have here open up. This is the price when the trading was open at that day. High is the highest price of the day. Low is the lowest price, and this is the price where it closed. Okay, and the volume of transaction, and then this is the adjusted price is because of stock splits or dividends. Okay, so going back here, so these are our variables. Okay, now if you recall, what's this, guys? This is subsetting, right? Subsetting. So what are we subsetting here? Okay, what are we subsetting here? We can subset, if you recall from what we discussed a while ago. Here you're subsetting, okay, remember this is the row, okay, the first one, and then comma, and then the column. For the second one, for the column, we know that's all the columns, okay, all the variables. And then this will only be, okay, see the first 5 rows, and then n row gives us the number of rows of apple 1. Okay, so if I example, if I run that n row AAPL1, okay, I'm running that function, that code, n row apple 1, it gives us the number of rows of the object apple 1, 2769. Okay, so let me check apple 1 here below, apple 1. Okay, let me just check here. Okay, I hope it's the apple 1 there. Apple 1 has 2769 rows, right? So this is correct. 2769 rows. Okay, so what is this function? What are we doing here? We are asking R to generate, okay, rows 1 to 5 and the last row, and give us all the columns. Okay, so we are subsetting just the first 5 rows and the last row. Okay, remember n row apple 1 gives us 2769. Okay, so let's run here n row apple 1. So let's run this. Okay, so it gives us the first. Okay, let me run run it again. Okay, so notice it gives us the first 5 rows, the sum January 4, 5, 6, 7, 8 of 2010, and the last row, December 31, 2020. Okay, so that's subsetting the first row and the last row and all the columns. Okay, so here it's apple 2. Okay, here's a note, guys. It gets the end of the week prices usually Friday, unless Friday is a holiday. So when we get weekly prices, it gives us the price on a Friday, the Friday of the week. Okay, here is an example of apple 3. This time we're getting monthly prices. So let's run this apple 3. Okay, and let me access that apple 3. And then we find here that there are only 132 entries. Okay, so it's from January 1, 2010, so monthly, February, March, April, until this is December of 2020. So these are monthly prices, and of course we expect the entries or the rows to be less than the weekly. For the weekly, it's 574 entries, and then for the daily, it's 2,769 observations. Okay. Okay, how about annually, guys? Will this work? Periodicity annually from 2010 up to 2021. Will this work? If we run this, okay, so this doesn't work. So the argument should only be daily, weekly, and monthly. So no annual data given. Okay, so here are just some notes here. Yahoo Finance weekly and monthly volume. is the average volume and not the total volume for the period. So it's the average volume. Okay. Okay. So here, let's continue, guys. Okay, we have some more minutes. Let's cover as much as we can. Okay. Definitely, we won't be able to finish everything today, but definitely, guys, next meeting we will finish everything, and then we move on to another R file. Okay, so we'll keep on increasing our knowledge of R and working on how we use R as a trading software. Okay, so what's the class of Apple one? We know that this is, this is an XTS object, or it's also called a zoo object. They're almost the same. Okay, there's some difference, but a zoo object is also a time series. This was actually the original, okay, but it's now expanded to be XTS object. Okay, dimension of Apple one dimension is the number of rows, 2769 by 6 columns, and we have already run this a while ago. These are the variable names of Apple one. Okay. All right, so here is some explanation about XTS. Okay, even though the data frame object is one of the core objects to hold data in R, it's not really efficient when you're working with time series data. So we did data frame a while ago. If the object, if the data has time series, then it's not really efficient. So when we're working with time series data, it's best that your data frame object be converted into an XTS object. So what's the difference, guys? Remember, for a data frame, okay, for a data frame, the date will be one variable. The date will be located as one variable here. For an XTS object, the date is the index. It's not included as a variable, which makes it easier to handle and easier to manipulate and easier to work with. Okay, especially when you're working with time series functions. Okay. All right. So let me move on here. All right. Now here, guys. Okay. Now, if you notice, guys, you have this open, high, low, close. Now, this data is used to generate what we call the candlestick plots. Okay, have you encountered candlestick plots, guys? Candlesticks. Ronnie, have you encountered this candlesticks?
I can.
Have you seen candlesticks before? Candlestick plots of stock prices?
No.
No, not yet. Okay.
Yeah.
Oh, sister, have you encountered candlesticks?
No.
Not yet. I'm sure she Love, you have already encountered, right, Love?
Yes, sir.
Okay, good. Thank you, Love. And Robbie? Is Robbie still there? Okay. So, all right. Now, we will be working on plots of this. In quant mode, it's very easy to do that. Okay, so here we ask, is Apple one, does it contain OHLC, open, high, low, close? And we expect the answer to be true because indeed Apple one or Apple 3 for that matter. Okay. Let me just delete this. Okay. Apple 1, okay, we're working with Apple 1. Okay, so it contains open, high, low, close data. Okay, so that's OHLC. Okay, so does it have volume? Has that vo? So it asks a question that does it also have volume data? It's true. Okay, so we know head. Okay, head of the opening prices of Apple 1. Okay, so this just gives us the opening prices. If you run this, okay, the first 10 of the opening prices. Okay, and the tail of the adjusted prices. Okay, tail of the adjusted prices. The last 6. Okay, this is the last 6, and then this one series high tells us what is the highest. What's the highest price? Okay, of Apple 1 here. Okay, so let's run this again. here. So the highest price, okay, highest point, okay, 138.79, and this happened on 12/29/2020. Okay, and then the series low here, it's the lowest. So this gives us that's January 29, 2010. The series low was 6.79462. Okay, so these are some of the things that we can work with when we use quant mode. Now, plotting data also is very easy in quant mode. So here, this is the base R function, plot Apple 1, and then let's just plot the adjusted price. So this is not from quant mode, okay? This is from base R. Okay, let's plot this. Okay, so here is the plot for, okay, we plotted the adjusted price, okay, plot Apple 1, Apple that adjusted, and we can use quant mode. We have chart series. Okay, let's compare the plot. Okay, so see the difference, guys, in the plot. The plot of quant mode gives us really more information. Okay, see this, guys? So what do you think generates a better graph? Is it the plot function in base R, or is it the chart series plot in quant mode? Of course, I know you know the answer. Okay, I know you'll tell me that it's the chart series of quant mode. Okay, but of course we cannot see this too much, okay, because it plotted everything. We can do a subset. Okay, we can do a subset. Let's see. Do I have a subset here? I didn't include the subset here. Okay, anyway, we'll do that next time. Okay, here you're doing here subsetting, okay? Head, so this is the first 6 elements of open and close of Apple 1. Okay, so but what we're doing here is that we're getting the percentage change, okay, from opening to closing of Apple 1. By how much did the stock prices change? Okay, so first six observations, okay, here. Okay, so for the first day, January 4, open, close, the percentage change. Okay, let's validate this. Let's validate this, okay, here. Okay, and then we'll end here, guys. Okay, wait, before we go, guys, okay. Do I have Quandle here? Did I include Quandle? Okay, no, okay. So we were not able to finish everything here, but next meeting we'll finish this, we'll finish everything, and then move on to another session, more lesson. Okay, so far, guys, how do you find quant mode? Any comments? How do you find quant mode? You hate it? Hello?
Yes.
You're so quiet, guys. You're so quiet. Okay, so let's just finish a few more, and then we'll call it a night. Okay. I wanted to validate this opening close. Okay, it's 0.0027. So it means that the closing price of January 4 was higher because this is positive relative to the opening price. So let's take a look at that. January 4. Okay, how much was the opening price? So the opening price was this amount. Okay, so let me just copy that. Control C. It's here. Okay, and then close. Close is this one. Control V. Oops. What happened? Okay. So that Control C. Oh boy. Okay, so let me just, how do you get the percentage change? The closing divided by the opening. We copy the opening, Control C, okay, Control V, and then -1. Okay, I'm getting the percentage change. So opening, closing. So the closing was 7.64. The opening was 7.62. And since the closing is higher than the opening, then we have a positive answer here. Control Enter. And did it match, guys? 0.02717. Then correct. Okay. So correct. We were able to validate that indeed this was the opening and closing. Okay. Change. Then the second one is negative. Let's just see. Negative. Oops, I closed the. Okay, so if you check, if you take a look at your Apple One data, I accidentally closed it. The could you tell me which was higher, the opening or the closing in January 5? Okay, I think some of you were not yet able to download the data. So the closing, the opening for January 5 was higher than the closing of January 5. That's why here you're getting a negative answer here. Okay, so let's just finish this line. Okay, we can also get here the percentage change between the opening of the second day versus the opening of the previous day. Okay, so we're here getting the ratio, getting the percentage of the opening of the first day and the opening of the second day. Okay, of course here we can use the round function. Okay, because there are many decimal places here, we can round it off to 5 decimal places. There, just 5 decimal places. Okay. Also, the percentage change between the the highest and the closing. Okay, highest and the closing. So round. This will give us everything. Okay, okay, there. High, close. Okay, everything, guys. The percentage change between the highest and the close. The high price at the beginning, the highest price at the certain day, and the closing price. Okay. All right. So, any questions, guys? Any questions so far? Let me put here end of lecture for November 12. Okay. So next meeting, we're going to finish everything. May I request you guys to please go ahead and run this. Okay. There are not so many codes here because there are so many notes here. So please, study this ahead of time. Okay. I will finish this next meeting, and here you go to kindly see other sources. Wanda, okay, this is good for foreign exchange, and Federal Reserve, Federal Reserve. Okay, I forgot this is in St. Louis. Okay, so this is the data site for this. This contains huge amount of data. All right, so we'll have some examples of that next meeting. Okay, And then next meeting, we're going to continue with more quant mode. And then the next topic will be, now, may I ask you guys if, did you have in your, I'm thinking either we go already to machine learning, or do you want us to first use R in time series? Hello?
Theory.
Did you already learn ARIMA and GARCH in your subjects?
Yes,
Not yet, sir.
but not really understand.
Not understand. What did you use? What software did you use? Statistica?
Yeah, on the statistics on the time series, the professor not give us the what we call the application on the how to use account or compute time series.
Okay. So maybe we'll just have. And did you learn GARCH? Did you learn GARCH? No?
What's that?
GARCH. I think you maybe not, because you're not. I think you sound so surprised in hearing this. GARCH, did you learn?
No, sir.
No, this is generalized auto regressive conditional Okay. Did you learn GARCH? How to generate GARCH, guys? No? Okay, so after this, guys, we'll finish this next meeting, and maybe the first hour we'll finish it, and then we'll go to applications again of software in time series analysis. We will go through ARIMA and GARCH. Okay, and then maybe after that, some special time series analysis, and then we go to we'll go to let's see, maybe let's see if we can insert also some portfolio optimization using R. Okay, and then we go to machine learning. How about that, guys? I'm changing the syllabus a bit, because the syllabus was originally intended for VBA in Excel, but VBA in Excel for me is not really. It's quite antiquated and it's not powerful. R is really more powerful. Okay, I hope, guys, you have seen the power of R. I hope you have seen the value of R. Okay, so just a quick feedback, guys. Are you learning so far?
Yes, sir.
Yes, sir.
Sure, Ronnie.
Yes, sir.
How different is this from your trading software before?
Before we just use the Excel function.
Yeah, VBA, right?
Yeah, VBA. Yeah.
Yeah. So this is quite different.
I think this is much stronger than before.
Yeah, of course.
Yeah.
Yeah, R is really more powerful, much stronger.
Yes.
Yeah.
But my question is, why the same course has different software to teach?
Yeah, it's really up to the teacher. It's really up to the teacher to decide which software.
Because for me, this is really a new course than before. I think the same course, but it's very different.
Yeah, but I hope, Ronnie, you're learning. I hope you're learning.
Yeah, sure, of course.
Yeah, that's good. Okay, that's good. Or I'm just forcing you to say yes.
Yeah, I think if you learn, can feel happy. If you don't learn, you're boring.
So you're telling me I'm boring?
No, I feel happy.
Thank you. So I appreciate that. So I owe you a Starbucks for saying that. Okay. So are there any questions, guys? So let me stop recording first.